If you are learning cloud security, IAM is the first thing you need to actually understand. Not just know it exists, understand how it evaluates every API call. Because here is the thing, every action in AWS, whether you are clicking a button in the console or running a CLI command or your application is making an SDK call, is an API request. And every API request goes through IAM evaluation. There is no bypass. There is no admin shortcut. Even the root account goes through this process. Let me break down the 4 building blocks. First, users. These are permanent identities. Each one gets an ARN, can have a console password and access keys. Second, groups. Groups are just collections of users. You cannot log in as a group. They exist to simplify permission management. Attach a policy to a group and everyone in the group gets those permissions. Third, roles. Roles are the important one. When you assume a role, AWS gives you temporary credentials that expire. Default is 1 hour. No permanent keys sitting in config files waiting to get leaked. Fourth, policies. These are JSON documents that define what is allowed or denied. They get attached to users, groups, and roles. Let me show you what a policy looks like. A policy has a version field, always set to October 17, 2012, and an array of statements. Each statement has an effect, either allow or deny. An action field listing which API calls it applies to. And a resource field with ARNs specifying which AWS resources it covers. Here is a gotcha that gets everyone. If you are writing an S3 policy, you need 2 resource ARNs. The bucket ARN for operations like list bucket. And the bucket ARN with a /* suffix for object operations like getObject and putObject. If you only include one, half your permissions silently do nothing. You will not get an error. The actions that do not match just quietly fail when you try to use them. Now, the evaluation algorithm. This is critical. The default state is deny. If no policy says anything about an action, it is denied. AWS then checks all applicable policies for explicit allows. If it finds a matching allow, the action would be permitted. But then it checks for explicit denies. And here is the key rule, explicit deny always wins. Always. If you have 10 policies saying allow and 1 saying deny, the action is denied. This property is incredibly useful. It means you can create broad allow policies for teams and then layer deny policies as guardrails that cannot be overridden. For example, you can deny anyone from stopping CloudTrail logging, and no amount of allow policies can override that deny. Now let me talk about users versus roles, because this is where I see the most mistakes. IAM users have long-lived access keys. Those keys sit in credentials files, environment variables, CI configs. They do not expire unless you manually rotate them. And they get leaked. They get committed to Git repos. They get pasted into Slack messages. They get saved in plaintext on laptops. Roles solve this entirely. When an EC2 instance or Lambda function uses a role, AWS automatically provides temporary credentials through the instance metadata service. These credentials rotate automatically. Your application code does not need to manage keys at all. The AWS SDK automatically picks up role credentials. So the rule is simple: human users with MFA for console access, roles for everything else. Let me walk through a practical setup. Say you have a team of 5 developers and a security auditor. Do not attach policies to each user individually. Create a group called backend developers, attach the permissions they need to that group, and add users to the group. When someone joins, add them to the group. When someone leaves, remove them. When the team needs different permissions, update the group policy once instead of 5 times. For your applications, create IAM roles. If you have an EC2 instance that needs to read from S3 and write to DynamoDB, create a role with exactly those permissions, create an instance profile, and attach it to the instance. The application gets temporary credentials automatically through the metadata service. For debugging, 2 tools you need to know. First, AWS IAM Simulate Principal Policy. This lets you test whether a specific identity can perform a specific action on a specific resource without actually trying it. It tells you the result and which policy caused it. Second, Cloud Trail. Every API call, including denied ones, is logged. Search for access denied error codes to find exactly which calls are failing and which identity was making them. Tomorrow we are diving into advanced policies, permission boundaries, condition keys, and service control policies. These let you build much more sophisticated access controls on top of the fundamentals we covered today. See you then.